Hello. Hi, everyone. Welcome to the worksheet video for today. So we're going to do four of these integral problems. Let's see what we got. So first we have this guy with that part being infinity. So we have to rewrite this as a limit as t goes to infinity of t to. And I'm going to go ahead and take advantage of this and rewrite the power -3 dx. So this can be written as, well, first I'm gonna let the 7 escape. And we have x to the power of -2 over -2 from t and 2. I'm gonna simplify all constants. -7 over 2 limit as t go towards infinity of 1 over x squared from t to 2. Then you have -7 over 2. I'm gonna go ahead and now do that integration substitution part. We have 1 over t squared and then minus 1 over, I'll do it 4. We know that if the limit as t goes to infinity for this guy, that's going to be 0. And the limit as t goes to infinity for this guy is just a constant. So we have -7 over 2 times a -1 over 4, which is going to be a positive 7 over 8 as our final answer. All right. Oh, and then it does converge. All right. Over here, just real quick, we need to check if the bottom will ever be 0 in this bound. It will not. The only 0 that makes x to the x to the power of 3 0 is 0. Over here, similarly, this will never be 0 because that's always positive and then plus 1. So in that case, we can just start it. We have limit as t goes towards -infinity of t 0 of x over x squared plus 1. From dx, from here, I'm just going to use a u substitution. Let u be x squared plus 1, and let du be 2x dx. The 2 is not there, so I'm just going to go ahead and write as 1 over 2 du is equal to x dx. So I'm going to let the constant escape, limit as t goes towards -infinity. Integral from t to 0 of 1 over u du. Let me just double check. Yes. Then we know that this is just 1 over 2, the limit as t goes towards -infinity of ln of u from 0 to t. Plug in x. Ln of, what is it? X squared plus 1 for 0 and t. So plugging them both in. Now getting closer to actually using the limit part of this, we get ln of 0. I'm sorry. Oh, well, 0 plus 1, which I'm just going to cheese and write 1 already. And then minus ln of t squared plus 1. Okay, well, we know as t goes towards -infinity, the square of t will go towards infinity because a negative times a negative is a positive, and then plus 1, well, that'll be ever increasing. So this thing, as it goes towards infinity, will be ever increasing. So we can technically rewrite this, evaluating the limits. And I always forget if ln of 1 ln of 1. Yeah, it's definitely 0. So we can definitely just rewrite this as 1/2 times a negative infinity. And wouldn't you know it, that is not an actual number. Because that's technically, even though you're multiplying it by a half, it's still going to be infinity, so the whole thing doesn't matter, and this diverges. And then if you, I mean, you're not going to have a graphing calculator on the test, but if we want to look at it, you can see that if I do x squared plus 1, that's, it will just keep going. Oh, sorry, I don't know why I did this. It will just keep going down and down all the way towards negative infinity as t goes towards negative infinity. Even multiplying the 1/2, 0.5. Yeah. It'll go there slower, but it'll still go towards negative infinity. All right. And that's gonna be it for this part. Let's move on to the next page. Here we have to double check if that integral will be discontinuous at all. It won't. So we can just do the limits as t goes towards infinity of 1 to t of, I'm going to go ahead and rewrite this x negative 2 dx, which we know is a negative 1 over x with t and 1. So the limit as t goes towards infinity, negative, of 1 over t minus 1. Did we redo this problem? Did I just like redo a problem that we've done before? Oh yeah, it's the exact same one. Oh, it's good practice. Because for me, I just saw the problem. For you, maybe you took a lap and then you did the worksheet and you're like, oh, that's the same problem. Either way, we know we applied the limit of this, that's 0. And you apply the limit here, it's negative 1. So you have negative times a negative. This whole thing just comes out to 1, and it converges. All right, lastly, we have a double negative situation. We know that technically this will split up from negative infinity of 0, or going to 0 of this expression plus 0 to infinity of this expression. And then we could rewrite the limits for those to be limit as, let's go ahead and practice doing a different letter. So um let's do mm, let's just do a, as a goes towards negative infinity, a to 0 of this expression, and then plus the limit, and this one I'll use t, 0 to t of this expression. Now, notice that I'm technically taking the same integral, just with different bounds, so really it would serve me if I just do the integral on the side. Now, I see the derivative of this slightly appears here as a multiplicative product, so I can do u substitution pretty easily. Oh, I forgot the square. 4 plus 1 du is equal to 4x to the power of 3, and then dx. 4 doesn't exactly appear, so I'm just going to not worry about it and go ahead and divide by 4, so x to the power of 3 dx. So that leads this whole thing to be 6 over 4 integral of 1 over u squared du, which will be um, a negative 6 over 4 times 1 over u, and then plus c. But we don't have to worry about the plus c for this part. Actually, I'm going to do one more thing. I'm going to simplify that fraction. 3 over 2 times 1 over u plus c. Okay, so in that case, I'm going to go ahead and redo all of this with that in mind. The limit as a goes towards negative infinity. And technically, I can let the constant escape of negative 3 over 2 of 1 over u from 0 to a, and plus the same thing, a negative 3 over 2. The limit as t goes towards infinity of 1 over u. Oh, I forgot to plug in back u here. It doesn't matter, I can still do it. I just will have to take an extra beat to write it out. We can still very much do it. Well, in that case, I'll go ahead and factor out all of the negative 3 over 2. The limit as a goes towards negative infinity of 1 over x to the power of 4 plus 1 from 0 to a. And then plus the limit as t goes towards infinity of 1 over x to the power of 4 plus 1 t to 0. Okay, from here, I can go ahead and limit as a goes towards negative infinity of, this is all going to be 1 when it's 0, and then minus 1 over a to the power of 4 plus 1, and then plus, for this limit, as t goes towards infinity, we have 1 over t to the power of 4 plus 1, and then minus 1. Okay, so then from here, we see that because it's an even power, this bottom part will both go towards infinity when we apply it. And if they both go towards infinity when we apply it, then these will just come out to be 0. And then the constants are the constants. So we have 1 minus 0 plus 0 minus 1, which all comes out to 0. Which isn't the best result, but it's the result. It says what is this whole limit does converge into something, so the whole thing converges. All right. That's gonna wrap up this worksheet video. Let me know if you guys have any questions, and I'll see you in the unit 3. I keep wanting to say 2. Unit 3 review video. Bye bye.